Well, good afternoon. We're just about to embark on a session on cloud platforms and operational analytics. Excuse me, Hip, could you go back to the prior slide, please? Thank you. Just hit escape, please. Thank you. All right, excuse some of the issues, but no problem. But my name is Sal Spada, and I'm one of the discrete automation analysts for ARC Advisory Group. And I'll be moderating this session, which is on cloud platforms for operational analytics. And the primary area of discussion will be primarily discrete manufacturing applications. So with us today, we've got Will Sobel from a company called Vimana, so it's right here. We've got Vijay from a company called Sandvik, which many of you have probably heard of, or possibly not, but they're one of the biggest tooling manufacturers in the world, so they're building consumables for the machine tool market. And then also we have Joe Sanguinetti from General Mills, and I'm sure we've all consumed some product from General Mills. Okay? So with that, we're going to, this is going to flow as in the following way. I'm going to give a short presentation, and then I'm going to, each of these gentlemen will also give a short presentation. If you have any specific questions, I would encourage you to either write them down or hold them off. But if you feel a compelling urge to ask the question during the presentation, really don't hesitate, because if you felt it might add something, don't hesitate. So with that, I'd like to start talking about our perspective of how the cloud is, what the utility of the cloud, and what analytics can be applied on top of it in many discrete manufacturing applications. So one of the things I have observed, and because I've monitored the market, worked in the market for quite a number of years, over 30 years, and we all talk about digital transformation and IoT. And if you look at this picture, we look at the digital divide really about 30 years ago, when we had the product design, process design, all developed in a digital world. And then the manufacturing community would also develop their systems, whether in, combined digital analog worlds. And over time, the way the movement of information from the two worlds generally worked was paper documents, informal discussions, and things of that nature. However, the divide started to close over the last 10 years or so, where we started to look at the movement of digital information from the product design, process design, moving directly onto the manufacturing floor as electronic documents. And so that was really what we've termed almost a digital thread. And so we're seeing really a closure of that gap. And now I think when we talk about the industrial IoT, the use of data on the manufacturing floor, it's really how we're going to create a continuous loop of information flow to improve both design, product design and process design. So one of the things I like to look at, and I'm sorry, this is kind of the architecture of how the cloud will play in all of these developments within the further closure or the loop closure of that whole digital world. And certainly the cloud has played a big role, and it has a very compelling argument in terms of its use, in terms of supporting software infrastructure in a manufacturing plant. We all know it's the cost of deployment of software in the cloud is much lower and has made it much more accessible to small and small-tier companies who generally can't afford the IT infrastructure. But most infrastructures aren't really ready to move data to the cloud. And so if you look at this picture, I've created something called the cloud agents. And actually, this wasn't my idea. This picture here is from a patent I dug up on the internet. One of the automation companies actually developed, is patenting the whole architecture of the cloud and cloud agents and the secure movement of data from equipment on the production floor. But one of the bigger benefits you're going to find is, certainly moving data securely without actually having to move through your control systems. And that's really the big benefit that the big advantage of when we talk about IoT today. You're no longer funneling data directly through your control systems, but you're able to use another conduit, and hopefully a cyber secure conduit, to move data into the cloud in a multi-plant operations, where you can derive extremely big benefits from sharing information across all of these different plants and improving your operational performance. Because now you're able to gauge one plant from another, derive, observe what might be what's deviating from, why there are deviations in one operation versus another, and then try to make the correlations. And that's the big use of big data. But within these cloud deployments, and we all talk about these multi-plant operations, but companies are also looking at expanding their reach out into these ecosystems. Your suppliers, whether it's the equipment that you're using, the materials you're using, but it becomes, you can start to look in reaching out into a bigger ecosystem as you move data into the cloud and start to create the infrastructure for sharing information. But another aspect is the fact that companies want to perform analytics in the cloud and operate on the data in your plant to improve performance. And so deployment, in many of the cases, is we're looking at these IoT platforms. And there are a number of implementations out there already being sold by the major automation companies. But the platform is one thing which sits in the cloud, but it's also the fact that you need to develop these applications, which may be domain-specific for your particular environment. And that's where the development of analytics for very specific operational issues will become important over time as we find domain experts developing applications on these open platforms that will provide customers results in their operations. And so here's an example of how we envision the use of the cloud, where we have data moving into the cloud, data scientists analyzing the behaviors in the plant and trying to isolate problems using more sophisticated analytics, and then pushing production rules back down to the plant floor, kind of creating this loop closure with the analytics and the production problems. And then over time, improving the overall process within your production plants. But what does this require? It requires really the extensive use of data, statistical analysis, and all sorts of models, whether they're predictive or prognostic, but they'll have a tremendous amount of utility as we go forward to provide the input that customers will need to operate their plants. And effectively, what we're trying to do is automate those decisions that would normally be a result of your workforce observations that would be manually collected and brought back to the design process. But now we're looking at this whole loop closure as a way to automate that loop closure. And so the other part of the loop closure, I look at the machine. The machine's providing that feedback loop. The machines on your production floor or production lines, you can't just think about an individual machine. You may think about the entire production line and how to correlate the behaviors throughout between the individual machines and try to improve the overall execution through this feedback loop. And from that, we talk about more and more of the connected machines. and this idea of bringing, how do we connect machines, whether they're legacy or new machines, in a secure fashion. But in the end, what we're looking for is trying to achieve improvement in our production goals, whether it's reducing the operation time to produce the workpiece, how much output the machine can produce on a daily basis, or improve our labor force in terms of their ability to improve the workpiece or produce more parts. But certainly there are many steps you can go through to improve your performance, and that is certainly use the analytics to identify operational issues that may be of significance. You can identify poorly operating machines, and in some cases we call that identifying the hidden assets, where in fact you recognize machines that actually aren't being utilized to the maximum. So in the end, we want to start to analyze the performance of the individual machines, the operators, and close the loop with the product design. So over time, the connected machine will play an important role. And who's going to be the who is really going to be the major player in that space? We're not quite sure yet whether it's going to be the machine builder, but there's opportunities for the machine builder, and that's what I'm trying to explain here through digitalization, through connecting machines in your plant and potentially sharing information with your machine builder, where they can start to provide more services. As many people have experienced over the last 10 years, the workforce reduction, the experience reduction, particularly in many of the discrete manufacturing plants, has been a real challenge. Particularly after the downturn, we saw a tremendous amount of reduction in the engineering workforces in many of these discrete manufacturing facilities. No longer, they started to push back to the machine builders to help them with their process issues and some of the production issues. So we see that actually that layover continues even to this day. Those engineering resources haven't been built up again. More and more machine builders are being asked to support additional services, from improving operations, providing predictive maintenance, and then even these will transform into more services that customers will be buying over time, which is a very important aspect of improving not only the health of your operations, but in terms of providing the machine builders with another source of revenues to make continuous improvement in their designs.